All right, everybody, welcome on in. So, where are we at with things? I think I mentioned this to your class, but I can't remember. So if I'm repeating myself, that's fine. And I'm just trying to make sure all my students know. Um, the school changed its policy that said even though many of us were teaching online, fully online, that we still had to have 60% of our office hours on campus. The union has negotiated that, and we now can have 100% of our office hours online if we were teaching 100% online. So what that means is for most of you, you probably have more access to office hours now, right? Because most people who are taking an online class are not going to go to campus, go through the screening process, find my office, and talk to me if they're taking an online class during office hours, right? So it's just these Zoom office hours. So my normal Zoom office hours that take place on Tuesday, Thursday, my Monday office hours will also be Zoom office hours. So 11 to 2 on Monday. If you need help, just hop into my office hours on Monday, those Zoom office hours, and you can get help, and I can answer your questions and whatever you need to know. Okay, so no more difficulty of having to go to campus. You'll just open the same Zoom link, come talk to me. I'll help you out. You'll move forward, be successful in the class. Okay. The other thing I wanted to mention. So, and this was weird because, sometimes with these software programs, the my view as the teacher is different than your view as the student. And so sometimes when students report things to me, it takes me a little while to figure out what's going on because like when I look at it, I go, well, it works for me. I don't know what's going on. Well, let's see. And I'm trying to figure out. That's why I usually ask students, like, can you show me a screenshot or give me like detailed information? Because it just helps me figure out what the problem is a little bit sooner. So the way that plus these softwares, they do updates and they move things around and they change settings and stuff. Like that was an issue earlier with Zoom when my Zoom meetings were messed up for a week because I couldn't figure out what setting they changed during an update. The bottom line is, well, not quite the bottom line yet, but the way Delta Math works is the teacher pays a license fee for the year, and then the students get to use it for free, which is a much better model because in many of my classes, each of you would be spending $100 on the homework. So it's nice that we can just pay one fee and then have all the students not have to pay because that's, at a typical class, that's around $4,000 students would have spent altogether. If you have 40 students and they're each spending $100, $4,000 the students would be spending on materials, whereas if we offer Delta Math, you don't have to pay anything. So that's $4,000 saved to that class, right? So that's preferable because believe me, I remember what it's like being a college student and not really having money for stuff. So what happened was my subscription to Delta Math ran out, but I didn't get an email or anything, so I didn't know. So there's a number of features that go away when and one of them actually was a test option, and I couldn't figure out where the test option went. But a couple of options were removed when my subscription expired. One of those is all the videos that accompany your problems. So once I went digging around to try to figure out, like, let's see, some students are saying that they're not able to see the videos, but I'm able to see the videos. So what's going on here? I dug around for a little bit and figured out it's because my subscription lapsed in October. At some point in October, my subscription lapsed. So I just I renewed my subscription. And so the video should be available to you again on each problem. So when you're trying to do a problem, if you go to do it, you should see that link now that says video or whatever it says, something about a video being available. So I know a lot of students, they don't read the whole page. They kind of just go to the part they think they need to look at. So if you notice that or maybe you didn't notice, but that the math videos weren't there, maybe you didn't use them in the first place, or maybe you just noticed like, oh, there's no more videos. And then you kind of get in the practice of not using those videos. They should be back for you on most of the problems. I think not every single problem has a video, but if you were wondering why aren't there videos anymore, they should be back. So if they're not, let me know and I'll look into it and we can again, I can't tell because it always lets me see the videos. But if you're having any kind of issue like that, let me know. Otherwise, just a reminder, there should be videos there for you to watch when you're doing the problems, and those are incredibly helpful to help you get through it. Sorry that there was the lapse and they were gone for a little bit. I didn't. It's weird when subscriptions end in the middle of a semester. You don't usually see that. I don't know why they don't have it renew in the summer, and then it would just sail right through the semester without having to remember to renew a membership. So anyways, look for those videos. Should be available for you. Okay? All right. With that said, all our hard work is actually going to get to something today. So we've been spending all this time on factoring, and I've been assuring you factoring is actually quite important, although I get it. At this point in the class, it would be reasonable for you to be skeptical and go, I don't know. I don't know if I believe you that factoring is important. When would I use factoring? Why do I care about factoring? Like, why is this something we need to know about? That's because we haven't shown you any of the reasons that factoring is important. Going forward, much of the algebra that you do will often involve a step of factoring. So today we will see the first application of factoring, which is solving equations. Solving equations is usually one of the big important things you do in algebra and calculus and that kind of stuff. Is you have an equation and you solve it, right? You could go so far as to some people would say that's what math is, and I would argue that's what math and algebra and calculus is, not so much when you get into other more advanced areas of mathematics. But you can make the case that in algebra, one of the really important things you do is solve equations, right? When you're doing research, you're solving equations probably. When you're working on business math, you're solving equations because you want to know, how can we optimize our profit? How can we lower cost? You're probably solving equations along the way. And then the basic problems that you're going to see, all these with context problems that students sometimes run into, the word problems basically, you're solving equations. So a lot of math comes down to solving equations. Factoring is now going to allow us to solve types of equations that we never ran across before. And they are ones that come up a lot, right? When we start solving quadratic equations, I know some students are like, why are second degree polynomials like so important? Why do we spend so much time on second degree polynomials and solving them? Well, for one thing, solving some techniques used for solving second degree polynomials, a lot of that work carries over into solving other types of equations. But also there are many, many things out there that are described with second degree polynomials. Oftentimes your cost function for a business is described with a second degree polynomial, a quadratic. Oftentimes in research, you'll have behavior following the pattern of second degree polynomials, quadratics. Gravity, so those of you who take physics, you start doing problems with falling bodies. That doesn't mean like human bodies. That just anytime you drop something in physics, they call it a falling body. So it could just be an object. Some of your laws that your formulas that you'll use for gravity, second degree polynomials. Okay, so they come up a lot in a lot of different areas. Just like lines. Lines are first degree polynomials, and they come up all over the place, right? So lots of problems can be turned into solving a linear equation. Also, many, many problems can be solved by being turned into a second degree polynomial equation. So these are important, okay? Now, what I'm going to say is, remember that not every polynomial is factorable. So we're going to be looking today at a technique for solving equations for polynomials using factoring. Well, then it stands to reason that if we're dealing with a polynomial that is not factorable, then we will not be able to solve it using a technique that involves factoring, right? That makes sense. So just be aware, this technique does not work for every single quadratic equation that you run across. So you go, oh, well, then that doesn't sound very useful. Well, here's the issue that we're going to run across. Later in the semester, we are going to learn the quadratic formula. The quadratic formula works for every single quadratic equation. Every single second degree polynomial equation can be solved with the quadratic formula. So you go, well, that seems like the tool to use. Why don't I just use the quadratic formula every time? Well, it's the proverbial using a sledgehammer to to nail in a thumbtack, right? It's way overkill. The factoring method is much faster and much easier when it works. The quadratic formula is more work, but it's your safety net for when factoring doesn't work. Okay, so we'll learn that later. But for now, just know that. Like when we get to the quadratic formula, it's not the most fun thing to go through and do. It's not like an exciting math problem. You're going to be glad when you get to one where you're like, ooh, this one's factorable. I'll have this one done in 20 seconds, right? And then you can blast through it. And then the quadratic formulas will take you a couple minutes probably to get through. So that's kind of the balance. Do be aware in an upcoming chapter with rational expressions, we're also going to be using factoring for completely different things. So while we're learning one way that factoring is important today, factoring is important for completely different things down the road. Okay? All right. With that said, what do we need to know? We need to know what is called the zero factor property. Sometimes this goes by slight variations in name. So sometimes it's called the zero factor property. Sometimes it's called the what are the other ones they call it? Zero multiplication property. Like there's all these different variations, but if the word zero is in it and factor, or sometimes it's called a principle, it's all the same thing. So don't think that they're talking. I forget exactly what term they use in the Delta Math when they do it. In fact, let's go to one. See, and that's what I was talking about, the watch help video. Make sure you use those when you're doing these. They don't really call it by name. They just say set the factors equal to 0. That's okay, because I will give you the information that you need in order to do these. Okay, so the zero factor property states this. It says if we have two algebraic expressions, a times b, and they equal 0. So in other words, we've taken two different expressions and we've multiplied them together, and the outcome was 0, then one of two things must be the case. Then either, can't hit the right buttons this morning, then a equals 0 or b equals 0. And that's a very special property. That doesn't work for other numbers. Oops. That doesn't work for other numbers, right? So sometimes people look at it and they're like, yeah, obviously. But like you got to think about it for a second. If I multiply two things together and I get 0, then one of those two things has to be equal to 0. That's why it's called the zero factor property. It only works for the number 0, right? So let's do an example. If 5 times 0 equals 0, which it does, then 5 is equal to 0, or 0 is equal to 0. Well, yeah, that makes sense. 0 is equal to 0. If you change either one of these numbers to be not 0, you won't get 0 as an answer, right? So when we multiply things together and get 0, one of the things that we multiplied had to be 0. It doesn't work for other numbers. For instance, it doesn't work for this. So if we say if a times b equals 6, then a equals 6 or b equals 6. Is that true? If a times b, if I take two numbers and I multiply them together and I get 6, does one of the numbers I multiplied together have to be 6? No, because my a could be 2 and my b could be 3, right? What if a is 2 and b is 3? That breaks the whole thing. So it doesn't work with other numbers. It only works with 0. And this is the reason you have to have your equation set equal to 0 as one of the steps in our process. I will see students try to use the zero factor property when they don't have 0 on one side of the equation. They're jumping ahead and getting into the factoring, And that kind of makes sense because we have a whole chapter of factor, 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 factor. That's all you're doing is factoring, right? So I know you've been trained to factor as soon as you can, but you have to get 0 on one side of the equation. If you don't have 0 on one side of the equation, we can't use the 0 factor property. If we can't use the 0 factor property, then nothing we do today works. It all falls apart. Okay, so just keep that in mind, right? So what this says then, let's get rid of some of this junk. What is this? If a times b is equal to 0, then a equals 0 or b equals 0. That means that what we're going to do, remember when we talked about factoring? Let's do one really quick. We talked about factoring versus multiplication. So remember x squared plus 7x plus 12. That was the multiplied out version of the polynomial. If we factor it, we get what? X plus 3, x plus 4. Remember, one of the big reasons that I kept telling you we were factoring was because we want things written as a product. Well, this isn't written as a product. This is. So why did I say it was so important that things be written as a product? Because then we have our a times b. This expression right here is your a. This expression right here is your b. Okay, so if these two things are set in an equation equal to 0, then either the first thing is 0 or the second thing is 0. We'll plug them right in here. So remember when your teachers, you might have heard this in the past, your teachers are like, set your factors equal to 0. Set your stuff equal to 0. But you didn't know why. You're like, why am I setting things equal to 0? Why is that what I'm supposed to do? This is why right here, because we're using this line. So I will refer back to that numerous times. So let's actually solve a slightly different problem. Let's do this. Solve minus x. And then now we're going to set it equal to 0. So for the first time you have an equation in this chapter. So far what you've been doing is you have expressions. And I expressed at the beginning of the chapter, make sure you recognize the difference between an expression and an equation, because I see students getting mixed up and trying to do the wrong thing at the wrong time. So remember, there's 2 clues when you're given one of these problems. The first clue, let me wait till that goes away so I can, there we go. The first clue is the directions, right? And I know it sounds, to many students, it sounds silly when I say that. There's many students who do not read the directions on a problem they're doing. They just dive right into it, right? I've seen that in Canvas where students don't read the direction, and I've seen it in on homework where students do not read the directions. They do the wrong thing, and then they're like, well, but my work here is right. Yeah, you did good work for the wrong problem. You made a different problem, and you did that one. So make sure that the work you're doing is appropriate to what you've been given. Here, your goal is to solve, and we're exploring what that means today. And what you have is an equation. You can't solve an expression because there's no equal sign, okay? And generally, technically, you could factor the equation, but that's just one step for us. If you stop at that, you've stopped halfway through. So when you see expressions, you think factor. When you see equations, you think solve. But then there's always that safety net to kind of reassure you're doing the right thing, which is the directions to the problem, right? Read those directions. Okay, so let's even make this a little more complicated. I'm actually going to mess this up just so you can see what's going on here. Say this is the equation I want to solve now. I'm making it a little bit more complicated. X squared minus x equals negative 12. Well, remember a moment ago when I made, actually, I think this has to be positive 12. Yeah. Has to be positive 12. Okay, remember a moment ago. Yeah. A moment ago when I talked about how none of this works if we don't have 0 on one side of the equation. If we don't have 0 on one side of the equation, then you're not going to get this, because this says 2 things multiplied equaling 0. Well, then we need 0 on one side of the equation. Now, you could get everything on over here, move it to the right, but you'd have a negative x squared. Usually you want to get things where the x squared is positive. It just makes it a little bit easier and cleaner to do. So what I would do is I would just subtract 12 from both sides of the equation. So I'm going to go, okay, I need to get 0 on one side of the equation. So to do that, I'm going to subtract 12, giving me x squared minus x minus 12 equals 0. Now we have that equals 0 piece that is so important. Okay, great. So we're kind of there. We have the equals 0 part. I've got my equals 0. But now what I need, I don't have the a times b piece because this is not a product. Boom, that's where we're going to factor, right? That's where I keep saying factoring is important because it allows us to write things as a product. Okay, factor that. All right, so we're going to do that, giving me what? X minus 4, x plus 3. Yeah, okay, good. For a second, I thought it wasn't going to come out right, but it is going to come out right. Okay, so step 1, I got 0 on one side of the equation. Step 2, I factored the left side, but now notice we have what we want. AB equals 0. Here is my A. Here is my B equals 0. So I'm going to write it there. AB equals 0. Do you see how I have that? That's why we write it as a product, so I can get that A and B in there. So this is my A, this is my B. Well, the zero factor property says, well, then either your A is equal to 0 or your B is equal to 0. So let's write that out. So this means that x minus 4 equals 0 or x plus 3 equals 0. So I did this piece. The A equals 0 is this. The B equals 0 is this right here. Okay. And you go, okay, well, that's fine. We still have some equations to solve. But look at the equations we have to solve, right? We turned one quadratic that we didn't know how to solve into two linear, like simple linear equations that we do know how to solve. Okay. So then we just solve those. All right, so the first one would mean that x equals 4. I'm going to have to move this up. And the second one would mean that x equals negative 3, right? You just solve this. Here you would add 4 to both sides, you get x equals 4. Here you'd subtract 3 from both sides, you get x equals negative 3. So this is, something just happened. We got two answers, right? Sometimes when you hear people talk about math, they'll go, what do you like about math? Oh, well, there's always a right answer. There's always one answer. Well, sometimes there's more than one answer. There's two answers here. This has two answers. X equals 4 or x equals negative 3. Both of those are solutions. And in mathematics, when we say solve an equation, we mean find all the solutions. It's not enough to find one. You got to find all of them. Okay? Now, like most things in mathematics, it's usually more difficult to find your answer than it is to check it. So how would I check these? Okay, well, that's not too bad. You just plug in your answer. So if I plug in x equals 4 into the original equation, I'd get what? 4 squared minus 4 equals 12. Is that right? Oops, 4 to the 4th. That's not right. 4 squared minus 4 is what it should say. Let me put in a word here so you can see the separation. So that way you see them separated a little bit better formatting. 4 squared is 16, minus 4 is equal to 12. Yep, 4 checks out. 4 is right. Okay, let's check out negative 3 then. Okay, so if I plug that in, that's going to be negative 3 squared minus negative 3 equals 12. Is that true? Well, let's take a look. Negative 3 squared would be 9, and minus negative 3 would be plus 3. So 9 plus 3 equals 12? Yeah, that works. So we know 100% the work we just did is right because we got two answers. We just verified them. They are both correct. Okay. One thing to keep in mind about polynomials, and some of you will prove this if you're in a college algebra or pre-calculus class, you go much more in depth with this. But a nice rule of thumb to remember is that the number of, for a polynomial, the number of solutions you get is the degree of the polynomial. So remember all our work with linear equations? What did you generally get? One solution. Well, a line is a degree 1 polynomial, so you get one solution. Notice how here we're doing a quadratic equation, a second degree polynomial. How many answers did we get? 2. So any of these quadratics should have 2 answers to them. Okay, if you solve a third degree polynomial, which you'll do a little bit of in this chapter, guess how many answers you're going to have? 3, right? So if you solve a 15th degree polynomial, you're going to have 15 answers. Now, we're not going to do anything like that in this class. In fact, most people never do something like that. But whatever the degree of the polynomial is, that's how many answers you get. And it's just following this basic procedure. You get 0 on one side. You factor what you've got. You set those factors equal to 0. You solve those equations, and then check them to make sure you're good. Okay? That's all it is every time. The only step that changes really is this part where we factor. But the good, right, because we can have, one problem might be a difference of squares problem. One problem might be a trinomial like we just did. Sorry, I got the hiccups are trying to come up right now. You might have a factor by grouping problem. So the factoring technique you use might change, but the overall behavior is going to be the same every time. Like you could just list these out, like make a little note on a piece of paper for yourself. Get 0 on one side of the equation, factor the polynomial, set the factors equal to 0, solve, check. Right? Those are your steps. That's what it's going to be every single time, assuming that the problem is factorable and that you can actually go through and factor the thing. Okay? If there's any questions on that, let me know. But we'll take a look at a couple. So let's look at one. Solve for all factors of x by factoring. Okay, so they've told us to solve. So I'm reading the directions. It's a solve. And there's an equation in there. Just a reminder, again, we have those help videos in there, which can be super helpful. So we want to solve this thing. Okay, let's solve that. X squared minus 2x minus 12. X squared minus 2x minus 12 equals, and then was it 2x, negative 2x plus 4? I don't know. You'll notice the same thing I've recommended for you when you're trying to learn formulas is to say them. And you'll notice when I'm trying to remember a formula, I just say it as I go to the other screen. Helps me remember it. Let's see if I got it right. X squared minus 2x minus 12, negative 2x plus 4. Okay, we want to solve this. And I should go ahead and say solve. Okay, so we're supposed to solve. We have an equation. Everything checks out. Let's get into it. I gotta remember to keep moving this back and forth. If I change frames and I don't move it over so that you can see, go ahead, just let me know in chat. Okay, so first step, get 0 on one side of the equation. So do we want to move everything to the left or move everything to the right? Technically, you can do it either way, but it's easier if your x squared is positive, meaning I'm going to take these terms and get them over here. So I'm going to add 2x to both sides, and if I do that, I'm going to get, our x's cancel out. If I add 2x to both sides, they're gone, right? These cancel out. This negative 2x plus 2x, no x's. Negative 2x plus 2x, no x's. So those are gone. Now I'm going to subtract 4 from both sides of the equation. When I do that, I'm going to get minus 16 equals 0. Okay. So step 1, we got 0 on one side of the equal sign. Check. Okay, now what do we have to do? We have to factor. So I look at this and I go, which factoring technique am I going to use for that one? Let's see. Well, there's 2 terms, and they look like they're squares. So that is a difference of squares, it looks like to me. It's on. Just making sure that's on. Sometimes it shuts off and then it won't recompile when I'm typing. So if I factor that as a difference of squares, That's going to be, hopefully you're saying it in your head because you're comfortable with those by now. X minus 4x plus 4 equals 0. Okay, I've got the thing factored. All right, well now it's pretty straightforward. I set those factors equal to 0. So x minus 4 equals 0, or x plus 4 equals 0. Solve those two equations, pretty easy. Either x equals 4 or x equals negative 4. So in this case, we'd get x equals 4. And down here, we'd get x equals negative 4. Now, just for the sake of time, I'm not going to check both of these, but it's a very easy exercise. I mean, I won't write it out, but it's a very easy exercise to go back and just plug in 4 and see if it works. So let's see. If I plug in 4 on this side, I get 16 minus 8, which is, so it'd be 16 minus 8, which is 8. Minus 12 is negative 4. If I plug that in over here, I get negative 8 plus 4, which is negative 4. Yeah, I think that's what we got. So that checks out. And if you do the same with negative 4, it's going to work. So you have your two answers, 4 and negative 4. So let's go back. Let's see. I think they want them with a comma, if I remember correctly. So let's do negative 4, comma 4. Oh, yeah. See there, then it opens up the... If I move it to a certain spot, it just automatically wants to fill the whole screen. I wish Windows didn't do that. It just sort of pops to the whole screen. Anyways, these are my two answers, negative 4 and 4. Remember, this curly bracket means set. And so this is our solution set. The things we found are negative 4 and 4. I hit submit answer. There we go. And then theirs looks just like mine, right? X squared minus 16 equals 0. They factor it. They set the factors equal to 0, solve each, and then you get your solution. So it's the same thing we just did, even though it's a different type of factoring method. Same thing. Set equal to, like they're even listing them right here. Set it equal to 0. In general, it's going to say factor, but in this case, it was the perfect squares. Difference of squares. Set the factors equal to 0. Solve remaining factors. Okay. What's the next one going to be that it gives us? Actually, I want to do a different problem because sometimes people get confused about a thing that I said a moment ago. So let's look at this problem. Let's look at one where I say solve x squared minus 8x plus 16. Is that going to be right? Yeah, that's going to be right. Equals 0. Okay, so we're trying to solve this one. Oops. Sorry, I keep having to change my screen so I can show the stuff I want, but then it makes it hard to write sometimes. Okay, so I go to solve this, and I'm going to get that. We've got, let's see, if I go to solve this, it should be x minus 4 times x minus 4. Now, when I solve this, look what's, or when I set my factors equal to 0, I get the same thing both times, right? So x minus 4 equals 0. Or x minus 4 equals 0. And you might go, well, wait a minute. I'm going to get the same answer for both of these. I'm going to get x equals 4. Which is fine. That's correct. X is equal to 4. But you go, wait a minute. You told me every single quadratic that I solve, I should get two answers. Now, some people don't like this answer. But then it makes more sense if you take college algebra or pre-calculus, where we deal with this a lot more, and then you sort of see the bigger picture about why we make this statement. Technically, we did find two answers. They just both happen to be the same thing, okay? So we got two solutions. We got one from this equation, which is 4, and one from this equation over here, which is 4. Now, usually when we state our answer, we don't say the answer is 4, but also the other answer is 4. It's just kind of a waste of time, right? If you're solving a profit function and it shows that your profit is optimized when you sell 500 units a month, you're not going to tell your boss, well, if we sell 500 units, we'll optimize profit, but also if we sell 500 units, we'll optimize profit. That just sounds bizarre. They would look at you like you're maybe having a stroke or something. They'd go, are you okay? Because it's just weird. It doesn't like, it throws people off, right? We don't, when we're dealing in context with something, it doesn't mean that you have to state both answers, but you want to recognize we technically did get two solutions. They just happen to be the same thing. Just like with identical twins, they might have, identical genes, but that doesn't mean they're the same person. You wouldn't go, well, you two are just the same person. They're still individual humans. They just are identical to each other. That's what we have here. We have two individual solutions. They just happen to be identical to each other. Okay, so yes, this actually still holds where even for this equation, what I said is true. You get two solutions. You'll expand on this, those of you who take college algebra or pre-calc, in a thing called multiplicity. We would say that this equation has multiplicity 2 because this solution occurs twice, and it actually changes the way the graph looks. So it's not just like, I'm not arguing semantics. It actually, you can tell from the graph if you have repeated solutions or not. So in fact, there are two solutions. They just match each other. Okay. So just be aware of that. And I don't remember how Delta Math wants you to answer that, but it should be obvious if you run across one of these. If it probably just wants you to put 4, not put 4, 4, but you can mess with that when you get to it. Let's see. We've got about 12 minutes. Let's look at some of these other ones. How about factoring a cubic? This is going to throw some people. 3x cubed minus 24x squared plus 21x equals 0. Oh, man, that's like a whole separate thing. We've been talking about factoring quadratics, and now you're talking about cubics? All right, let's give it a try, because what you're going to see is if you follow the directions that you've learned so far in this chapter, there's no difference. You're good. Like, you just do the same thing. A lot of times students will see a problem that looks different, and they'll go, well, what am I supposed to do here? What are the directions here? Well, the first thing you should do is always check, do my old directions still work here? And in this case, the answer is yes. The old directions we've been following will still work for this problem right here. Let me show you. So we have 3x cubed minus 24x squared plus 21x. Okay, I'm probably going to forget that, but 3x cubed, and then there was what? Plus 24x minus, what was it? Minus 24x squared. Plus 21x, okay. Plus 21x equals 0. So we're supposed to solve this equation right here, and that should be a 3, right? 3x cubed minus 24x squared. 3x cubed minus 24x squared plus 21x equals 0. Okay, so we've already got 0 on one side of the equation. Okay, check. We don't have to worry about that. Now our second step says to factor. So we're sort of, some students are like in panic mode right now because they're like, that's a cubic. We haven't done any cubics. What am I supposed to do with that cubic? Just take a deep breath and follow the directions which say to factor the left side of the equation. Now, let's see. If we think back to our factoring, when I look at this, I go, well, kind of looks like there's a greatest common factor in there. And didn't we say that that's always step 1 for factoring, that we should factor out the greatest common factor? Yes. And remember I told you before, when you factor out that greatest common factor, just keep writing it in front. That's because we need that factor to get us one of our solutions. If you forget that part in front, some students just stop writing it, you will be missing one of your solutions. And you'll get to the end of this problem. We expect how many solutions? 3. If you forget that part in front, you're going to end up with 2, and you're going to go, wait a minute, why am I missing one of my solutions? And the answer is because you didn't factor right. So let's take a look. Okay, so I'm going to factor out what, a 3x Okay, so if I factor out 3x, that's going to leave me with x squared minus 8x plus 7 equals 0. Did I get that right? Let's see. X squared divided by 3, 8x plus 7 equals 0. Yep. Okay. So I got that. Okay, so we did the greatest common factor. We factored that out. But remember we talked last time and said whenever you factor something, look at the remaining factor and ask yourself, can I factor it more? Can I factor that again? Let's try it. So 3x, see I'm still writing that 3x out front, but now I'm going to factor what's inside. So let's see. My signs are the same, so it's going to be x minus using our, it's an x squared here, so that has to break down as x and x. This tells me the signs are the same. This tells me they're minus, so x minus. Looks like it's 7 and 1. 7. Oops, that's not even a 7. 7 and 1 equals 0. I see a lot of times where students will stop writing the equation. There's always this, students are always wanting to write as little as possible, but again, it's go slow to go fast. If you take your time and do the steps correctly, you will actually finish faster than if you're trying to skip stuff. So see how I don't have the equals 0 here? I see that when I'm grading papers, and then the student kind of forgets what they're doing, and they forget, oh, I was solving an equation, because they don't even have an equation anymore, right? So always make sure at all steps that your stuff is written as an equation. There should be an equal sign in there. The equal sign doesn't go away. Okay, so now we just expand. We set the factors equal to 0. So 3x equals 0, or x minus 7 equals 0, or x minus 1 equals 0. Is that all going to fit? I think I can get it to fit. Oh, barely. Okay, anyways, that's all we needed. So now we have those 3 equations. Each one of those is going to give us a solution, and when we plug it in, there should be 3 correct solutions. So we should get, well, if I solve this equation, I just divide both sides by 3 and I get x equals 0. Here, add 7 to both sides, x equals 7. Here, add 1 to both sides, I get x equals 1. And we can see if I plug in 0, we can see pretty easily we get 0 on the left. So we get 0 equals 0. Okay, that one works. That's the one that would be missing if you stopped writing this 3x like some students do, where they just focus on the part that's in the parentheses, as if, like in math, we can't just wish things away just because they're inconvenient or we don't want them there. You would be missing this x equals 0 solution if you didn't have this piece. And a point about x equals 0, I'll see students get x equals 0 and they'll go, oh, so it's no solution because 0 is nothing. No, 0 is a legitimate number, right? You can have $0 in your bank account. That is, this is a thing that can occur. 0 is a perfectly good number. It's a solution. So that's our first solution. X equals 7 is the second one. That would take a little more time to plug in 7, but it's doable, and you could double check it works. We should be able to do 1. That's going to be what? 3 minus 24 would be negative 21 plus 21 equals 0. Yeah. So 2 of them we could check in our heads. The other one would require some scratch work in order to work through, but those should all work. So let's see, 0, 1, and 7. Let's go put them in the problem. So 0, comma, 7, comma, 1. Okay, that's right. That's how they do it, is whenever you put the comma, it expands it into a set. Okay, and you can see it's the same thing that we just did. You factor it, get your factors there, get them all, you're done. So the fact that it's a a third degree polynomial, don't overthink it. It doesn't actually change the thing. Now, there are third degree polynomials that you cannot solve using this manner, but any of the third degree, like in this section on factor cubics, you're going to be given problems that specifically can be factored in this method, okay? So then when you get into these other ones, these trinomial ones, it's the same thing, right? So if we look at one of these, what are you going to do? You're going to get 0 on one side. You're going to factor the polynomial. You're going to set the factors equal to 0, and then you're going to solve those. What about the factor by grouping? Same thing. Look, we already have 0 on one side, so now you're going to factor this, except you're going to factor it by grouping, right? And you're going to get how many answers? 3 answers, right? And they say find all real solutions. That means ones that are in the real number system. We haven't looked at complex numbers yet, so they should all give you... Yeah, we haven't even dealt with square roots yet. So try to do this one. We might have to come back to this one a little bit later. Try to do that. Don't worry about the homework. I'll adjust it so that, but it's good for you to get practice with some of these. It's going to give you an understanding of where we're going in the class. But if this one section's a little hard for you, don't panic on that. But the rest of these, you should be able to do all of these problems up here. Okay? All of those. And then we'll get into some of that other stuff in later sections. So if you can't do all this factor by grouping one, don't panic. We'll get to it later. Yeah. Right? So, okay, so there's that. And then next week, so make sure you're caught up. Right now, start getting caught up. The whole goal, sometimes people go, well, there's a tendency more and more as each year passes where there's more and more this idea that students should wait till the deadline to do homework. No, you should do the opposite. You should be doing it as soon as you can. Try to get caught up on your homework now, because what you should be focused on next week is studying for the exam. Okay, that's what next week is about, is studying so that you can get an A on the exam and you don't have to do a retake. Okay, so pay attention to that. Just try to do that. Try to get yourself caught up so that you're ready to go, so that you can actually focus. Because otherwise what happens is in a class like this, when we're doing review, there's always maybe like a third or half the class that are still focusing on their homework. So they're missing the whole benefit of the review because they don't have time to pay attention to it because they're doing homework. All right. So try to get your homework done now. And then next week, I will show you the practice test. You'll go through a practice test. Later in the week, you'll have a slightly different version. The rules are a little different on the test versus the homeworks. The rules are a little different, but that's okay. They're not like that much harder. It's just you don't get to keep trying problems endlessly and stuff like that. So you can take the practice test. You'll have that to sort of guide your studying, to inform you as to what problems you need to go back and look at. Then later in the week, you'll have your actual exam, and then we'll get on to the rest of the semester from there. Okay? Is there anybody have any questions for me? No? Okay. Good work, everybody. I'm going to leave Zoom open for a few minutes, so anyone who wants to hop into Zoom and speak with me before you don't see me for, 4 or 5 days or something like that, feel free to hop in there, talk to me. I'll help you out. I'll leave Zoom open as long as people are talking to me. Otherwise, get yourself caught up on homework. I will see you next week. Thanks, everybody.